Next thing we want to know is, well, what is it that determines where we are on this locus? What is it that's important for that? So what we're going to do is develop the counterpart for our two-stock formulas with n stocks. So now we're going to put a proportion pi1 in x1, pi2 in x2, and so on up to pi n in xn. The portfolio return is going to be pi1 x1, pi2 x2, and so on up to pi n xn. Now the portfolio variance, sorry, let's do the portfolio mean first. The more portfolio mean, what do we know about means? What do? They add. So we know that the portfolio mean, EX, is just going to be pi1 EX1, and so on up to pi n EXN. For the portfolio variance, we've again got our formula from here, EX minus EX squared. And we can substitute using X and EX. If we do that, we get it's the expectation of pi1 x1 and so on up to pi n xn, and then we're subtracting the mean, which is pi1 ex1 and so on up to pi n exn. And then that's squared. So you can group the terms together just like we did before, and then we end up with E times pi1 x1 minus ex1 plus pi2 x2 minus ex2 and so on. We've got xn, pi n xn minus exn. Now we could square it, but let's actually write it out in full so that we can see which terms we get. So we get the same thing again. And then we can square it out. Now, when we do the first term times the first term, what's that going to give us? What kind of term do we get? It's going to be pi1 squared times ex1 minus ex1 squared. That's the what? That's the variance of x1. So our first term is pi squared times the variance of x1. When we multiply this term by this term, what do we get? It's a covariance of x1 and x2. So we get pi1, pi2 covariance x1, x2, and so on. The final one is going to be this term times this term, which is pi1, pi n, covariance x1, xn. If we keep on going, this is going to be pi2 x2 minus ex2 times pi1 x1 minus ex1. That's a, what is that term? Variance or covariance? It's a cross term, so it's a covariance. So we again get pi1, pi2, covariance x1, x2. And then when we get the second term times this, times itself, we get a what? Variance. And so on. So we get pi 2 squared times the variance of x2. As we go down, all the diagonal terms are going to be what? They're going to be variances because you're getting the term by itself. And what are all the off-diagonal terms going to be? Those are going to be covariances and covariances. How many terms are there in total? N squared, n times n, which is n squared. How many variances? We have n variances, so how many covariances? N squared minus n covariances. Does everybody see that? So, let's do one final step. So the variance of our portfolio is going to be all the diagonal terms. That's the variance term. So it's sum from 1 to n of pi I squared times the variance of xi. And then we've got all the covariance terms. So that's the sum from 1 to n, and j equals 1 to n. We already got the diagonal terms, so we want the off-diagonals. In other words, I not equal to j. And then we've got pi I, pi j, covariance xi, xj. That's for the sake of illustration. Suppose we have equal weighting, so we put pi I equals 1 over n. And we can write this in a somewhat different way. Pi I squared we can take out. It's just what? It's 1 over n squared. And then we've got the sum of the variances. Now, one way that's quite useful to represent it is to divide by n and multiply by n. So we stay the same. What's the sum of the variances divided by n? What is that? It's the average variance. So we can write that n over n squared simplifies to 1 over n. So that's the average variance. And then we've got pi I, pi j. That's again 1 over n squared. And then we've got the sum of the covariances. We want those to be in the same format. So we're going to divide by what? Yeah, we're going to take the number of covariances, n squared minus n. We're going to multiply by it to keep the same. So n squared over n squared is 1. N over n squared is 1 over n. And then this term is just what? If we add up all the covariances and divide by their number, we've got the average covariance. As n becomes large, what happens to 1 over n? Goes to 0, becomes small. What happens to the variance term? That drops out. This drops out. And so we're left with the variance of the portfolio is the average covariance. That's why we're so interested in covariance, because what determines the risk of the portfolio is the average covariance. What happens to all the variance terms? They just drop out. This is why our gold mining or gold prospecting stock that we had last time wasn't risky, even though it had a big variance, because the variance terms just are insignificant relative to the covariance terms, because you've got lots of covariances and not many variances if n is big. Are there any questions on that? What we'll see next time is that the way that we're going to measure a stock's riskiness is, in some sense, its average covariance with the other stocks. That's effectively what beta is. So I'll see you on Thursday.